Welcome you all to this session, and we are going to the first session, that is panel discussion. It is the first of its kind in our institute, and in this panel discussion, we are going to interact with our dignitaries on the dais, Dr. Ashok Pandey, Dr. Mohammed Nasser, Professor Singh, and we are having Dr. Karthik Rajendran from SRL. I would like to give a brief introduction about Dr. Karthik Rajendran. He is Associate Dean at AIR, Associate Professor in the Department of Environmental Science, working in the field of energy, and a process design, techno-economic analysis and life cycle assessments of biomass and waste to produce bioenergy and biochemicals into biomethane. So he is having 68 publications, cumulative impact across 589 plus, and he is having 17 chapters. He received 2.8 crore funding from various agencies. He is having 5 patents. His achievement is 32. He is included in the world top 2,000 scientists list issued by Stanford University. So I invite all the dignitaries on the dais to share their experience to motivate us towards research. Please, sir. So I request all the dignitaries to give a brief overview of their expertise. So please.
As you heard before, I'm originally chemical engineer, and I studied bioscience in my PhD in 1999, so about 25 years ago or longer. And then what we focused especially was that if you can convert different types of waste and individuals into value-added product. So from one side, we see and that is the fact that biotechnology actually can do. From one side, they convert all this, whatever that has a low value or minus value, we can call it waste or residuals or some material which have some kind of difficulties. And on the other hand, we try to use different biotechnological processes, different microorganisms and different processing technology in order to convert them into different value-added products. Among the value-added products, I can say that they have this bioenergy, that they have different number of biogas, and also they have chemicals, different type of chemicals, polymers or biopolymers. They have also, say, food and feed. That is what we are focusing on. So we say that in general, we say whatever that you have, whatever that you want, we try to find a way to convert. On the other hand, also we are working with different type of different companies. So many companies that have collaborations, some kind of startup companies, some kind of big companies, in order to take this knowledge to society. So it's not going to be only publication, so it's going to be a real product at the market. That was on me. So I will talk a little bit later today on the part of this work, which is how to use this anaerobic digestion to make it as a more valuable technology to produce different type of product. Thank you.
I started my graduate research in 1997. It was a very long time. At the time, when I suggested this idea to the Society of Korean Scientists and Technology, many people say you must be crazy, but why you want to treat the carbon dioxide? At the time, there is no interest in the carbon dioxide reduction. But after that, as you know, in 1997, there was a very big event internationally about climate change. People get the idea and need for some international contract about climate change. That is Kyoto Protocol. So the Kyoto Protocol was a very important event in the world, and then people agreed to reduce or at least maintain the level of carbon dioxide in the world, in our air. After that, I could receive a huge amount of research fund from the government and company in Korea. So I never worried about the project in Korea because a lot of competition has and the investment has been made to the carbon dioxide reduction towards. Anyway, we are doing some huge size carbon dioxide conversion process by biological method. You know, carbon dioxide is very stable material. It cannot be easily converted to other chemicals. That is the problem. I mean, sometimes carbon dioxide is too stable, so we have to put in the energy into this chemical to convert the carbon dioxide into other chemicals. So, but the problem is the energy is another source for carbon dioxide. So in order to have the balance, then we have to use the sustainable energy. In our case, we use the sunlight, and that is, we know that the photosynthetic reaction. And nature has some answer to the climate change. But the problem is the reaction may be too slow, and our emission is so fast. So we find the best photosynthetic organism in the world is microalgae. That's why we are investigating the microalgae research. Problem is, we have no experience to scale. So our research focus on how to scale up the photobiological microorganisms. And so today my talk will be about how to scale up to 100 pounds, 1,000 pounds, 10,000 pounds, 100,000 pounds of photobioreactor is required to realize the carbon dioxide in the real field. And we just get the carbon dioxide from the industrial sector, and then we cultivate microalgae in huge scale. And then microalgae biomass has a lot of potential, such as beer, material, food, pharmacy. They can do anything. I mean, I think microalgae is our ultimate resources for human mankind. They can produce everything. Nowadays, we are interested in the plastic material from the microalgae. Because when we calculate the energy balance and the economic visibility, synthetic plastic, which has been produced from microalgae, has some potential to really commercialize. So that's why we are interested in how to produce the plastic from microalgae. And I think all of us are successful, and we try to find some good partners to start our business in Korea. And from our study, the sunshine is very important factor to determine the growth rate. So we are looking forward to the best place for full of the sunshine. And India can be one of the best strong candidates because the equator altitude is very suitable to have the full of sunshine from the land. So India can be a good candidate, very strong candidate to apply the huge size of microalgae cultivation in the near future. So that is our line of my research. Thank you very much.
Ravi has already introduced me. First of all, I would like to thank Ravi for this is my first class where I am sharing with my professor Mohammed. So I did PhD with him. So this is a very great honor for me to share the dais with him. Of course, along with Pandey sir. So that is first thing. So thanks for the opportunity, Dr. Ravi. So with respect to our work, when I was with Professor Mohammed, I worked on techno-economic analysis and building a reactor system on from potable textile materials. So this was my work. Over then, I shifted different labs in US and as well as in Ireland, where I worked on life cycle assessment, building some reactor from the scratch for anaerobic digestions, and as well as power to gas concepts. These were all trend-setting topics of those days. And when I came back to India in 2019, we wanted to use different areas. Professor Mohammed has talked about, he has worked on being a chemical engineer transforming into a bioscience. I was the opposite. I was a graduate of BTech Biotechnology back in 2009. And then now I am working on completely chemical engineering aspects, where we merge cross-cutting areas of energy and AI. So AI is cutting across many different fields today, and we wanted to use those applications in the energy field, in the bioenergy field, in ethanol, in biogas, in various other applications as well. So that is the work we are doing currently. We have about 5 to 6 PhD students in our group and a postdoc, where we look on can we use the like we all do mistakes in our life, right? So from the mistakes we learn and then we optimize ourselves. Can the reactor do the same thing? Can a reactor be a self-learning bioreactor? Right? Can it learn from its mistakes or can it learn from its process conditions? Can it optimize itself? That is the question we are trying to answer. We have developed one prototype for the anaerobic digestion purpose, and currently we are working on other areas of exploring those reactors as well. Thank you.
Me again. How many of you know what is the purpose of this session? So actually, Dr. Praveen Kumar said that top 2% interaction with top 2% scientists according to the top 2% according to the report of Stanford University. Are you aware of just raise the hand how many of you know what it is? No one? From this side also. Well, when we do research, now there are several organizations. One of them is Stanford University since 2020. Before that, there has been climate analytics, which is an arm of Web of Science. Web of Science is the one that which publishes scientific reports and also evaluates different journals for their impactful research, and they determine what is the impact of the journal and so on. So there is a methodology adopted by Stanford University how to determine the impactful researchers in the world. And what is impactful research? That research which one has carried out has been published in some journal. And so there are several criteria to evaluate those publications. One of them that the paper, suppose I publish a paper, so my paper has been cited by how many other people. Cited means when other people do research, they read different related works, different published by different other people, and if they feel that my results and paper is useful, they will refer in their papers my work. So it will be so that is called citation. So one of the major criteria to determine impactful research is number of citations. The Stanford University does this analysis across the science and engineering subjects and identifies that who are the top 2% people in the world in different domains of science and technology and science and engineering.
And this is where the people sitting on this side for the people of dais have been listed in this list. That means they have been identified as a researcher who contribute as an impactful research. Impactful research, that research it has not only scientific value but has also application for the society. Alright? So I am also happens to be one of them. As for my research that I have been like one of you, coming from a very humble background. My father was a college teacher and I studied till first standard of my education in the medium. Subsequently, when I went to BSc, it was English medium, that was very tough for me. But then when there is a wish and determination, you can always achieve whatever you want. Moving on to research, I started to work on industrial fermentation, industrial microbiology, and then over a period of time, coupled it with environmental microbiology or industrial and environmental biotechnology. And moving forward, in the beginning of 2000, when the world started to realize that how to control this greenhouse gases emissions and biofuel were again reconsidered as a possible sources of also candidate which can contribute in controlling damage by greenhouse gas emission, by uses in petrol and diesel and so on. So I started to work on biofuel. So precisely my contribution currently are in the cross field, science and engineering, environmental sciences and engineering, industrial biotechnology and engineering, and operationally bioscience. Cross field research has been considered as very relevant, what we call normally as interdisciplinary research. Because if at all we want to move forward only from publication point of view, every research has some element which we find application for the society. And this comes much more, true, becomes much more true when we have interdisciplinary team of scientists and engineers and we think differently. And that is what they particularly engineers have very different kind of outlook. No? As a microbiologist, normally we think of as a biochemist, think of the process in a class of 100 ml, and if you do it in a liter, we call it a scale. If you just start processing, he's talking about a scale of like 10 ton and 100 ton and 1000 ton, and why not 10,000 ton? That's the kind of challenges, engineering challenges and scale of challenges. So what I'm trying to tell that doing research is very important to generate good science, doing good science. That's a primary aim the researcher should have. But research should also find some application and then it becomes impactful as a research. And in this context, again, one important point is that working alone perhaps is not very good idea. Almost entire 2% team which you can see in the list, if not 100%, but definitely 90%, are those who are having national and international collaboration and networking. That put a simple message, that reliability of research is much more when there is an international team or when there is an international team. And in fact, it is much more obvious than the one operated by individual or a couple of people. So it's important that we work like a team, and in research it is extremely important. The team development and team breakup, they are great value, and we need to understand the relevance and importance of working as a team when we have any research, not as a profession, of course, but it should be as a passion. So I don't know how many of you have captured this. If you have any curious questions come to your mind, if you want to ask us anything about specifically on the work which we are doing, or any general question, or anything. One thing you should keep in mind that hesitation is the worst for the personality development. And you should never think that if I ask a question, somebody will say that what is a stupid question. At times, stupid questions have great relevance, and crazy ideas have much more relevance. We have in the CSI crazy idea research fund, an idea which comes out of box, which nobody can think normal, and many people will laugh it out. But then at times, this crazy idea has great relevance in research. So with this, I conclude mine and Praveen, what do you?
Thank you, sir. The session is now open for discussion. Sir, sir, you can discuss with the experts. Anybody?
Good evening everyone. I'm Dr. Nadu from Biotechnology. So first of all, I'd like to congratulate you for playing world record and top 2000 rankings. So as per the latest research sanctioned projects, I would see that wastewater treatment and microalgae have become outdated or out of scope. So can you please enlighten us about the current research trending topics and the specialists for everyone on the dais?
But still, actually, they has a lot of potential to apply. Presently, for example, we apply the microbial for the lithium recovery of metal, lithium metal, because they use the ion channel to absorb the lithium ion from the resource or recycled battery, and then you can recover the combination form of lithium, for example. And nobody can try the commercialization in large scale of microwaves, even there is a very high potential. So I think this is a very important stage we can apply the microwave also. Direct carbon dioxide reduction or conversion technology. And so, still we have a lot of work to do with this subject. That is my conclusion. So you will see from my lecture.
I also make a small comment about this question. In general, if you have this biology or any other topic, we need the 3 factors which are important if you want to self-develop. One is the technical factor that we should think, and we normally talk about the technology. The second one, which is very important, is the economical factor. So if the products are expensive, nobody is going to buy it. And then, so we should always think about development technology. That would be also economically feasible. And the third one is sustainability. And that is, we say, term that if you develop technology that could fulfill all these 3 factors, then it will be developed. If not, then it means that the states will have some kind of development. Many of this development that we have in the world, we always only think about technology, not about other factors. That's sometimes that we very strong. And that's almost every question. fortunate to see Pandey because I am from Jalgaon University, sir, and I was one of the volunteers in the first BRSI conference. So, right now I am serving in INC Biotechnology, Hyderabad. We are having the R&D center at Hyderabad, and then mostly the wastewater and water technology. So, I extended the question of doctor, that what are the recent advancement in the sustainable technologies in case of, like I have recently attended CNA conference at IIT Kharagpur. So there was a theme of waste and wastewater treatment. So a lot of startup were there to have coming up with the new ideas like microorganisms and all. But in a global scenario, what is the really required in terms of the industrial input at the technology side, as well as the, we can say, biotechnology side? What requires? To commercialize those things are very difficult. At certain stage it comes, but to commercialize that, it requires a different inputs.
Well, you have asked the question, answer for which the whole world is looking. What process should be adopted so that it is economically viable? And there are two things. There is also wastewater treatment. We have to understand that there are elements of environmental sustainability. And then of course there is the process viable in terms of economic and process is viable in terms of economic. These considerations are in. Globally, wastewater treatment has been improved from 2 points. Firstly, now the focus is package. What are the benefits or how to control damage to the environment? Now, damage to the environment or benefit when the process is developed cannot be measured in terms of when there is a clean air that benefits the environment. It cannot be found in terms of water. When there is a clean air or when there is a clean water, there is a betterment in the health of the people all around. That also cannot be counted in terms of water. So I am trying to tell that the environmental benefit of any such wastewater treatment process cannot be weighted in terms of water. That has to be considered as a policy. Second point comes when water whether what are the advanced technologies or what are the technologies to be economically sustainable. Because this is a challenge. What is the need? If there is a mandate, if it is by regulation and also by practice, regulation. Not so if you have a industry that is a field of water and there is no option for you or you do not want to drive the inspector and just release your untreated water into outside the river or lake or water. So technological development has completely reoriented in the last 20 years. Focus has been on resources. Sir, Mohammed Tahir, the head of for resource recovery, even the resource recovery, which has been established anywhere. So anything is not waste is what? If we do not know how to use this is a waste. Simple example, there is a chair in a city, if its overlay is broken, they'll throw it out of house saying that it's a waste. This one is waste for you, but not for others. So any kind of waste water, it has the organic matter, it has a nutrient, in fact the nitrogen is possible. So the focus is how to recover. And coming to your question, that what are that was, but macroalgae research has been needed for biofuel production, not for other applications. So high value product generation from this sustainable and development process where this carbon dioxide program is coming out from thermal power plant is utilizing to grow macroalgae, that is hematophobus, and producing aspartate. Cost of pure 100% pure that has been $250,000 US if you then think that one. Even the food as AstraZeneca is $7,000 if you look at fruits. And AstraZeneca is the one which is required which is being used more and more in cosmetics and many other pharma applications. So it is necessary. So wastewater treatment currently in India and across the world is being using methodology. But you do have benefits. One, that methodology biomass to be utilized for multiple applications, not necessary for high-value product production all the time, but possibility are there. Depending on the chemical composition of that biomass, what type of liquids are there, in different applications. And at the same time, there is a treatment reduction in CO2, and also this nutrient product. So it is very healthy. So for example, if it is a dairy industry based and if we have a macroalgae including hematopoiesis, then it can be predicted for us in production or in production and so on. But if it is a textile industry based, then it cannot be for such cool application. But then also biomass whatever is there, it can be used to make packaging, to make synthesis, to make bio-oil and so on. So this is where the focus is there currently. Principle of advanced technology. These are not advanced technology, but then these are technologies which are being considered that not only they are environmentally very sustainable, but they will have opportunity to offer environmental benefit as well as perhaps economic benefits. Okay, example I have given, but that is unending. We know that large number of common treatment plants which are there in China, they use it for what has been done in at large scale for different agriculture. In the untreated common composition from leather industry, this is not very successful for some kind of treatment, but that treatment increases the cost. So it is still at the but eventually there may be some bit of point where considering the environmental benefit and also whatever the byproducts which are generated as bioproduct, biochar, bio-oil, and then there are the application of the diet of multiple application. Perhaps this may be one of the solutions. Okay? Thank you. Thank you.
Good afternoon everyone. I am Arunai from Chemical Engineering Department of RRFP College. So my question is regarding waste utilization. Currently we use crude oil and we produce 7 basic chemicals to fuel our whole petrochemical industries. So what I would like to ask is there any scope for our waste that we produce every day to be utilized for producing these 7 basic chemicals, so that we can either supplement or substitute our crude oil utilization and then produce these petrochemicals in a more sustainable way? And if yes, if there is scope, then on a global scenario, what is the technical and economic standpoint regarding this?
Thank you. Interesting question. But I rephrase your words. There is no waste. We talk about waste, but I don't see any waste. I just find these resources that sometimes is that natural resource. And the point is that whatever that you have, for example, if you take this one, as long as it's used, then it's a resource. If it doesn't work, then we throw it away, then it's some waste. So if we change our mind in order to say, okay, this is some kind of valuable material. What is this one? We can say, for example, there are some kind of plastics and maybe some inks and some kind of metals. If we develop the knowledge in order to utilize that one, then become something interesting, then become a new material. The problem is not the waste, the problem is our mind. It is not the waste. If we can develop it, then we have, for example, in Sweden, we don't have any municipal waste. Everything is recovered, so they have zero waste. And many other countries, they have zero waste. What we are doing, we are making money. We don't throw away. They just making money from wastewater, from everything. That is, and we are not happy. We are still developing further, so we should be better and better. So we are just making more money. One thing that you should think, for example, if you are developing something, I think that is the main issue that we have I see everywhere in the world. My question to you and also to all of you, if you are going to do something, are you ready to sell your house or your parents' house and put it on that topic or not? If you are ready, it means that you believe in that one, then you can be successful. If you are not ready, forget about it. You are not going to succeed on anything. Because you don't believe in yourself. And if you want that, you should be more businessman and not a scientist. We say if you want to develop. Make money, convert everything into money. Is it possible, for example, to make money if you take municipal waste? What can I do with municipal waste? What is municipal waste? It's a combination, a mixture of this. You have, for example, food waste, which is a protein, starch, carbohydrates, fat, and all of these things. These are valuable materials, but we cannot use it. That's why we throw it away, from waste. And then we have to pay someone to take it away from us. But if you just turn your mind and that's okay, these are valuable, how can I extract, how can I make, for example, new material, then becomes certain interesting things. And then that is what we have to play with and to change our mind, and if we succeed, then it becomes successful, of course, and we can, there is no waste. I would say that we came from Jamaica here. I told Arunai and Singh that we have a very beautiful area, I say like a paradise, except the garbage. If you remove the garbage on the street, then you are in the paradise. But you have this garbage, make a problem. But why do they throw it away? Because they don't have the knowledge. What is not valuable material? That is the thing that they have to change it. I will talk in my presentation a little bit about what we do, just part of it, not a following question. But you should think, for example, take an example and develop it on almost everything.
Thank you for all the people, including Tiruvannamalai. They are doing very good research work for all biotech and Biotechnology. Thank you for all the people. One small information, I am creating a defense. Now, in Kerala, small village, they develop sustainable energy and biotech materials available source in their ground itself. They make 3 years before one project and they sustainable continuous energy they are getting it. In such a way, in your country, what all things are going on, please come and give the information.
If I just take the street as an example, they have, we talk about this renewable energy, we are something around 60% of all energy is renewable. And we talk about this coal fuel, electricity, heating, everything. We talk about 60% renewable. It was not like that. If I go back, for example, 20, 30 years ago, the level was 10-15%. But it increased earlier, they reached that level. And it is a hard work that we have by the government, by the people, by the education, university, developing technology, and also implementing the technology into the society. That's one of the most difficult parts. In India, I see also a lot of good development that we have in India, and but still, I would say that we are lacking the education. That is one of the main things that I see myself in India part. We develop education and this new technology which can be fit into this country, then it can be also well developed and you can implement it. One big mistake that many countries they try to copy. For example, the Germany has done something and we want to take it in India, which doesn't work. Well, Germany has different infrastructure, different culture, different need, different type of capital. Here is different, so we have to develop something that will work here in India. That is the one which is we say that one missing part. I think the whole key issue is education, and then you have other factors which comes in like regulation, laws, and also this companies implementation to bring it in. But if you work long term, then you can achieve. And they have to definitely have a long term plan. And I believe that this is the only way that we plan in the future. We cannot do as what we are doing now. It's getting worse and worse.
Good afternoon, all the panel members. So, this is Dr. Pratish from Commission. Actually, my question is related to Professor Ashok Pinda, Ashok Pani. So, as you talked about the 2% scientists, and this will be quite different from whatever the theme is. So, I wanted to ask something that in many of the cases we see that people compare among themselves that yes, I have a publication with this much impact. While others say that yes, I have a journal with, I have a publication with this much higher impact. But in my opinion, I think that like impact factor doesn't matter as much as the citations or the index of the author matters. But still, the government agencies, when we go to apply for a job or some position, they ask for a paper along with the impact factor. So, could you clarify like what is the best option or what it is actually the debate between impact factor and the citations?
Like the debate between good and bad is unending. Same story goes with impact. Impact factor was invented by scientists named Arunai in United Kingdom. After inventing, then it became common and it was adopted by the journals, and that time it was recognized by a company called Thomson Reuters. And subsequently, so what had changed and taken on this level analysis. And because science is the parent company. So 10 years down the line, I wrote an article. I'm talking of 80s, that it was I think 1986, supposed to be like that. Impact factor use or abuse. And he gave a lot of examples and analysis, data analysis, but he left the answer for the readers to decide whether impact factor is being used or abused. He did not draw any conclusion and left the people to draw. And today also is time to think. What is very clear that there are lot of views opposing impact factor, opposing impact factor, and for sure this is not universally accepted ideal indicator. But then, in the current situation, globally, for more than 90% organizations and institutions and scientists and producers, more than 90% accept it as one of the best indicators. It is not the only indicator, it is as one of the best indicators. But then, when it comes to assessment, custom area, recruitment, use and abuse, and as long as the humans are involved in using or abusing impact factor, how and which way to go study. Did you understand? Same person says that you go for a thing, and you are like a X is having very high impact factor. The stand here is when I go for it, same person will say, what is the great thing that you have for publication in a higher plan? What is the use of that? To use and abuse both things. It changes the person to person, time to time. It is not better use and abuse.
you all. Thank you for the panelists and thank you for the participants. Due to reach short of time, we are forced to close this session even though we are having many questions from the participants. I request participants you can easily interact in person one-to-one during the free times. I hope panelists are available to you. So now we can close this panel discussion. Thank you for all. We will go to the next session.
We hope that this panel discussion and insights shared here will serve as a catalyst for your progress in research and innovations, and let's strive for excellence. Now I request Dr. Ashok Pandey to honor Dr. Karthik Rajendran. Sir, please.
లంచ్ లైవ్ లో